Hey, South Africans. We are Robo-Door, your burglar.
Sound check. Sound check. Good morning all. Thank you for joining my webinar this morning. This webinar is Inventor Introduction to Design Accelerators. We will have a look at the basics of some of the design accelerators, the tools and calculations that's available. I am Gideon Besaidnout and I am an application engineer and technical consultant for micrographics. If you'd like to receive more information or you would like to contact me, please see my email below. You'll see there's my email details. So let's get started. So on the agenda it's the introduction, generators, basic of design accelerator tools, how bolted connections work, basic of frame generators, shafts and gears, and then the conclusion. So introduction. Design Accelerator consists of two main tools, generators and calculators. So generators, this is standard components that will be created. It will have custom geometry that's based on the standards. Calculators, this is performance-based, has multiple solution goals, and does not create geometry. The Design Accelerator tools are available in assembly. So let's have a look at some of the generator tools. So you get your bolted connection, you get your shafts, your gears, bearings, keys, disc cams, and there's so many tools you can use in the generators. Calculators. This is the calculation that's being done on Inventor. For instance, to see if the assembly will be able to take the actual force or can it withstand the friction, to name a few. Calculators, this is performance based, has multiple solution goals and does not create geometry. So some of the calculations we can check is actual force, friction, elasticity, yield strength, and allowable thread pressure. And this is just to name a few of the calculations that can be done in Inventor. So let's have a look at one of the tools that's available in the Design Accelerator tools. So we're going to have a look at the bolted connection. So what does the bolted connection do? It designs and calculates pre-tense bolt connections and performs a strength check. You can design bolted connections with unlimited number of fasteners, use custom parts, create only holes in your design and enter them into the assembly. And fasteners are available from the Content Center. And as you know, Content Center is pre-standards and specifications that's loaded into Inventor. You can also select the type of strength and calculation. Okay. When you select the bolted connection, the table on the right will appear. Like you can see here, you've got a few options you can choose from. So let's look at the difference. So first we've got the type. So you get two types, your through-all connection type and your blind connection type. So a through-all connection type goes through all holes or drilled through all the material. A blind connection type is the last hole is blind. So let's look at your placement options. So on the placement drop down, you get a few options. Your linear, your concentric, on point, and by hole. So what's the difference between linear, concentric, on point? So linear is just in conjunction with a straight line or edge. Concentric is concentric to a radius or a circle. On point is when a point was created. It will be placed on the point, and by hole is when the holes have already been created. Next, you get your different hole specifications and your different hole sizes. Like you can see, you get your different hole specifications and your different hole sizes. So, an example of a bolted connection. Here we have a fully constrained assembly. This is a simple block that's been fully constrained together. The holes have already been created in this example. So open the bolted connection, you'll see this table, and the type I chose the through connection type, and placement is by hole because the holes has been created already. So the steps to follow. The first option you have is your start plane. So with the start plane, I chose the front of the block because I want the bolt to be inserted from this direction. The existing hole command, I chose the hole, and click and add the fastener. So you'll see here you have this option where you can add your fasteners. So when you select a fastener, this table on the right will appear. This is all your different standard bolts that you get, and in this example I just chose ISO 4762. And if you repeat it after you have inserted the bolt, you'll see that you can insert washers. So in this example I chose ISO 7090. As you can see, only one hole has the bolt inside. So after you pressed OK or apply, you'll see that only one bolt and one washer was inserted. So how do we make sure all the holes are linked and have the bolts in? You will notice a new bolted connection has been created inside your browser. So that symbol means it's a bolted connection. So all you can do is right click on it and say edit using Design Accelerator. So then your bolted connection component generator table will open up again, and just make sure you click on the follow pattern. So when you select the follow pattern and you say OK, you'll see Inventor will automatically place all your bolts and washers into the block. So when all the bolts and washers has been inserted, this means the two blocks has been bolted together. So in Inventor you get different pins as well. So the calculation includes a strength check, parts material check, and the minimum pin diameter. So let's have a look at the different pins you get. First, you get your clevis pin. The clevis pin calculates, designs, and checks clevis pin joints. Then you get the secure pin, design and calculate secure pin loads with the shear. Then you get your cross pin, designs and calculates cross pins loaded in a draw rod and a sleeve. Then you get your joint pin, designs and calculates joint pin loads with torque. Then you get your radial pin, design and calculates the joint pin loads with torque. So let's have a look of an example of a secure pin component generator. So here we've got a fully constrained assembly. It's just two arms that are put together and it's been fully constrained. So we're going to have a look at the secure pin. So the secure pin designs and calculates secure pin loads with shear. Secure pins are available from the content center, so you've got your normal standards. Your calculation includes a strength check of the secure pin, part material check, and the minimum pin diameter. So steps that you have to take for the secure pin component generator. First, you select the pin tool. The type, I will select the through connection type, as you can see. Placement, I'll choose concentric. So the first option you have to do is your face. So I've selected this face because I want the pin to be inserted from that side. Then I chose circular. So the reason why I chose concentric is I wanted the pin to be inserted directly in the center of this radius over here. So for circular, you just select that radius. For your end plane, you select the back of your arm of the back part. Then you select your fasteners, and in this example, as you can see, the pins were open and that's all standard based. So in this example, I chose ISO 8748. After I chose the pin, you'll see that there's still a pin diameter. So one thing you need to remember, that's all standard based. So all pins, all bolts come in specific sizes, specific diameters. So I chose 8mm diameter. So now I'm gonna run a simulation. So on the calculation screen, I have chosen to run the simulation of the calculation on 10,000 newtons. The pin diameter is 8mm and the pin length is 15. When you choose to insert the pin, you'll see the pin length because, like I said, it's all standard based and specification based. So the bottom board thickness and the top board, that's the thickness of your part. So my part is 5mm thick. And the joint properties, I just left it as is. Here you get a drop down menu where you can choose your different material standards. So in this case I chose the steel 11 500 5D. You can also insert the available pressure and stuff like that, but I left it as is, and then I press calculate. So that's just to run the simulation. So now Inventor has run a calculation simulation for you to see if the pin you have selected will be able to handle this load. Now if you look at the right column, you'll see there's quite a few things in red. This means the calculation failed. It will not be able to withstand the force of 10,000 newtons with that diameter pin. So Inventor actually tells you the minimum required diameter of the pin to withstand that force. So what can we do now? Now we can edit our Design Accelerator and change the pin diameter to the minimum required to handle the load. So in your browser, you'll see you have your pin, you right click and you can just say edit using Design Accelerator. And that will open up your table again. And from there, all I did is I went and I changed the diameter to 14 millimeters. Now you'll see the new length of the pin is 28 millimeters. So that is as per the standards and specification. So all the pins come in different sizes, different diameters, but it's still specific diameters with specific lengths. So in this case, I just edit my part thickness just to be in conjunction with the pin. Because if you've got a 10 millimeter part but a 28 millimeter length pin, it will stand out quite significantly. So after I've changed my thickness, I'm going to redo the calculation. So the force still stays the same. The pin diameter I changed to 14 millimeters. The pin length I've changed to the standard length. And because I changed my part thickness to 10 millimeters, so my bottom and top it's 10 millimeters, and then I pressed calculation. After the simulation, you'll see nothing is in red. That means your calculation is successful. And so what that means, in Inventor with a 40 millimeter diameter pin and a 28 millimeter length, my two arms will be able to withstand the force of 10,000. So next we're going to look at the frame generator, and this is just going to be a summary of a frame generator. So what you get in your frame generator, under your categories you get all your different angles, your channels, your bars. As you can see, there's quite a few options you can choose from. Under your standard you get your ISO, your PSI, your DIN and your sans. You also get your different type of sizes, and remember this is standard based, so all your standard sizes will be there, and you also have your different material types. So this is what the frame generator table looks like once you open it. Like I said, with the frame generator there are a few preloaded specifications, from angles to channels, specifications and standards and material types. So you select your, so I've created a small block, and you select your standard, your size and material type, and then you select your insert points and make sure it is in the correct orientation. So when you insert your frame, just make sure it's in the correct orientation, and then you can say generate and it automatically generates a frame for you. And then you can actually go into your browser and you can hide the block that I've created, so then you've got your single standing frame over there. So let's look at some of your frame generator tools that's available. So as you can see, you've got your insert frame, insert end cap, your change, your miter, your notch, your corner joints. So this is some of the tools you get. So first we've got the insert end cap. So this places end caps on the selected frame members. Next you've got miter your corners. So miter your corners applies miter cuts as end treatments between frame members. So that basically cuts your corners. Then you've got your notch tool. So this removes material from one frame member to fit into another. Then you've got your corner joints. This trims and extends two frame members at their ends. Then you've got your trim extend. This trims or extends multiple frame members to a model frame face or a work plane. So let's look at a frame generator, a frame analysis summary. So you can create your simulation, you can run a frame analysis, and you have actually a few options. So frame analysis has managed tab where you can create your simulation. You can choose the simulation type between static analysis or model analysis. You can choose your parameters and rename your simulation. So with your frame analysis properties, you've got your beam properties, you've got your material properties. So on the right side, you can see, if you open this, you'll see actually every beam or every frame that you inserted, you can see their specific properties. If you click on it, you'll see, okay, this beam has this type of material, and this is the density you get, your modulus, your ratio, even your yield strength and tensile strength. You can see your linear expansion, your specific heat that's inserted at a specific point. So that's actually quite nice in the frame generator from Inventor. So your frame analysis constraints, so you do get different constraints that you can use when inserting frames. So I'm just going to have a look at some of the different constraints you do get. So as you can see, you get your fixed, your pinned, your floating, and your custom constraints. So what's the difference between using these constraints? So let's have a look. So first, we've got your fixed. So your fixed constraint removes all degrees of freedom from the selected geometry. As you can see, your fixed and pinned both select a beam or node to apply the fixed constraint. And so the difference between your fixed and pinned, so your pin actually removes displacement degrees of freedom from selected geometry, where your fixed removes all degrees of freedom. Next, we'll have a look at your floating pinned constraint. So this removes displacement degrees of freedom in a specific direction in a frame structure. Then you get your custom. So your custom defines degrees of freedom in a specific node of the structure. So as you can see, when you look at the pictures, you can see your different directions, the different constraints move, and with custom, you can select and actually customize it. Next, we're going to look at the frame analysis loads, the different load types that you get. So first, you get your force. So your add force defines a force of a specified magnitude to be selected on the beam or node. Then you get your continuous load. This defines uniform load distributed along selected beams, defines the direction and magnitude of uniform force. Then you get your general moment. So structurally loads of beams you select with a nodal moment of a specified magnitude and direction. Then you get your actual moment. This applies a nodal torque load in the plane perpendicular to the beam axis. Next, you get your bending moment. This applies a nodal bending moment in the plane parallel to the beam axis. Just important when you choose your loads, take a note on the different directions that you do get. So with your force, as you can see, look at the arrows. So it's going clockwise or anti-clockwise, or it goes down, where your bending moment actually rotates, your actual moment rotates around the actual. So you do get your different types of frame analysis loads. So that's also something that's quite interesting of Inventor. So with frame analysis, runs a simulation based on the specified configuration. Progress of the simulation is shown, and you can view the error and warning messages in the status node of the browser. Runs a simulation based on your configuration. So when you run a simulation, you can configure it with your different simulations. And as I mentioned, with your different types of forces. So your simulation will go hand in hand with your different force or continuous loads. So depending on what you select here, will be the outcome of your simulation. So after your simulation, you can even print your reports. And one of the most certain key areas is you can determine your displacement of your frame. So you can see, okay, you know what, on this point there's a displacement, and then you can look at your specifications you do get. So if your displacement allows a 0.025 millimeter and you see, okay, you've got a 2 millimeter displacement, you know that you need to edit your frame and add certain key areas. So next we're gonna look at another tool. So this is the shaft component generator. So this is actually a very nice tool to have, and it comes in handy. As you can see, here is a 4-step shaft that's been created. So if you look at the screen, you'll see 1, 2, 3, 4 steps. So here you can actually change your dimensions. You can change the diameter, the length. You can choose if it's going to be a cone or like the second step, cylindrical. You can make it a polygon. You can actually add chamfers, fillets, and if you look at the bottom, when you click on that drop down menu, there's actually more tools you can add. You can add a keyway groove, a retaining ring, a wrench. You can add relieve, add a groove, add a through hole. So this is a very handy tool in Inventor. So the shaft component calculation. So here you can determine the elasticity, determine the different loads, or even specify the loads. You can even specify the point that's going to take the most load. You've got your different forces that you can determine. And as you can see on your results, it can actually show you your eye load, your support, your mass. So this is a good calculation to see if you need to increase the diameter of a shaft, for instance, because it's taking too much radial force. So this is also quite handy to see if the shaft that you are making, if the calculation is successful, if it can withstand the load on a specific point. So you also get your shaft component graph. So this is the results of your bending movement, your results of deflecting angle, results of tension stress. So as you can see here on your YZ plane, your shear force, there you can see on your graph. So it actually also tells you your mass, your loads, your support, your tension, and you actually do get quite a lot out of this graph, a lot of information like your torsional stress, your tension stress. So this is one of the most handy tools for the Design Accelerator, for my personal opinion. It tells you so much about your shaft. So next we're gonna have a look at your gear component generators. So with your gears, you actually do get different gear types. You get your spur gears, your worm gears, and your bevel gears. You can specify your number of teeth, your pressure angle, and the center of distance. So You can even choose if you want your gears in mesh, or if you actually just want a single gear, if you want to insert a single gear. So then if you just want to insert a single gear by the gear 2, on the drop down menu here by component, you just select no model, and you can actually Inventor draws the gear for you. So that's also quite handy. So next we're going to look at the gear component calculation. This can assist to see if the gears in mesh will be able to withstand the load or last the required life cycle. Just a reminder of the life cycle. The life cycle is not based on nature or in-life production, because we all know many factors take place when it comes to the required life cycle and the actual life cycle that gears run. So in this calculation screen, you can, the method of the strength calculation, you can put your loads, material values, your required life, specify factors and accuracy. And that's, you can choose your material values for gear 1 and gear 2. So this is also quite a nice calculation to run. Next, we've got roller chains. This is just an example I created of a roller chain. So when you run the roller chain tool, the table on the right will be visible. Here you can select your chain type. So again, when you click on this drop down, you'll get your specific roller chains that's as per the standards, and you get your sizes. Then you can select your plane and your different type of sprockets. So this is also quite nice. So in your browser menu, in this example, I made the XY plane visible. So in your browser menu, by origins, I just made my XY plane visible. On the drop down here, I chose the ASME B29 40-3-90 chain. Then the plane I selected is the plane I made visible, it's the XY plane. Select the chain mid plane option. So the reason why I chose this is because I wanted it to be in the center of the plane. You can even offset it from the plane if necessary. You can create the number of chain strands, the number of chain links. You can select the position of your chain. Like you can see here, there's your different positions. You get your fixed position by coordinates, your fixed position by selected geometry, your direction driven sliding position, your rotation driven sliding position. So in this case, with the first sprocket, I just chose free sliding position. Also, when you look at your sprockets here, there's a drop-down menu where you can actually have your components, your existing component if you already created a component, or even create a virtual component. As well, when you click here on the drop-down menu for the roller chain, you can actually add the sprocket or edit the sprockets. You can edit the number of teeth. As you can see, there's a few options as well. You can even choose the direction that your sprocket wants to move. So note, you can do all different types of calculations, from power speed to torque, power torque to speed, and torque speed to power. So when you click on the drop down menu, that's where you find the different options. So as you can see on my left side, after I created the chain, it actually automatically created a whole sketch for me, just with everything I inserted. So that's also quite nice from the Design Accelerators. So when you do your calculation, you can see you have different options you can insert. If you can put in the power, the speed, the efficiency, the required service of life. And that's just to name a few of the options that's available in the roller chains. So you can, like I said, power, speed, application, environmental, your lubrication. So in this instance, I selected the power speed to torque, and the power I made was 2.5 kilowatts. The speed I made 450 RPM. The efficiency I left as is. The required service life I chose 15,000 hours. The application I made smooth, environment I made a clean environment, and lubrication I made recommended. So with the chain properties, I didn't add anything specific here or by the power correction factors. And I ran the simulation and I calculated it. So Inventor ran the calculation for us. So as you can see with the results, it's quite nice because it can actually go up to 2.5 kilowatts. So that's also quite nice and handy tool to have with the calculation. There are more tools available in Inventor. You get your different bearings types, you get your different belts, your like the roller chains I just did, you do get your V belts, your synchronized belts. With cams, you get your disc cam, linear cams, cylindrical cams. You get your parallel and involute splines. You do get your O-rings. You get your springs, compression, extensions, and that's just to name it, some of the tools that's still available in the Design Accelerator. So for me, the Design Accelerator is quite a very handy tool as it creates the drawings for you. You can run simulations, you can run calculations, and to see, for instance, like I said previously in the shaft, you can actually see if the shaft will be able to withstand the specific load at a specific point. When you insert the pin with your calculation, you can actually see if you are selecting the correct size pin, the correct standard pin. So that is something of Design Accelerator that I really do enjoy using a lot, and I really do love it. So for my conclusion of Design Accelerator, so why use Design Accelerator? So Design Accelerator enables the designer to insert standard and customized components and features into your model. It's great for ease of use when creating different configurations of parts and assemblies. Calculators in Design Accelerators can be used to verify your design. And just a reminder that real-life simulation will still be needed. As I explained earlier, like when it comes to your life cycle, Inventor can't work out the nature. If it's going to be in a water, damp, rainy environment, obviously that affects the material. So yeah, that's just something that you need to keep in mind. Your design accelerators can inform you if you are using the correct geometry, like I showed in the pin. So with the pin, I could see I can actually add material to my parts. So in some cases, you'll even be able to make your parts a little bit smaller and actually save on cost and save on material. So this is for me one of the most important parts of Design Accelerator, and the Design Accelerator calculation can actually save cost and can decrease errors in manufacturing. So when you run your calculations, it actually shows you know what, for instance, let's take the shaft for instance. Your 1 diameter is too small, and you run your simulation and you see with your calculation you need to increase. So if you did not run the simulation or the calculation, you would have manufactured the shaft as is, and down the line, while it's in production, it can break at a specific point. So that's why this is a very handy tool for me personally, because it can save cost and decrease errors in manufacturing. So thank you for being part of the webinar, and thank you for joining today. I really hope you enjoyed it and that you learned something today. If you have any questions or you would like to contact me or even contact Micrographics, as you can see, we've got a website. You can even email us or contact us. So thanks for joining and thanks for watching. And I hope you like and subscribe for more. And on our webpage, you'll see there are more webinars available if you are interested. So thank you again for joining, and I hope you have a fantastic day.